So section 12.5 begins on page 800. And we are talking about rational and irrational roots. Okay. So what's going to happen now is we're going to get exactly the same kind of things that we got previously, the same kinds of equations, but now they're not going to start us off with the very first roots. And so what we're going to start off with, for example, might be something like 2x cubed minus x squared minus 9x minus 4 equals 0. And we want to solve this. Notice they don't tell us that x equals something in particular is a root. So we have to do this on our own. So in order to do this on our own, we have to use something called the Rational Roots Theorem. And what the Rational Roots Theorem says, and again, you did this in Algebra 2. This is not new either. The Rational Roots Theorem says that any rational root of f of x equals 0 can be written in the form a factor of the constant term divided by a factor of the leading coefficient. With a plus or a minus in the front. Any rational root that exists. What do we mean by rational root? What are rational numbers? What's that? Not necessarily just real numbers. Well, I shouldn't say that. Excuse me. Not any real number, I should say. Those are the real numbers, not the rational numbers. What are the rational numbers? What does that mean? What's that? Doesn't go on forever? Okay. So it could be a decimal that terminates. That's an example of a rational number. But what's really the definition of rational numbers? It's something we went through at the beginning of the year when we talked about all of our number families. Rational numbers is one of our number families. No, it includes 0. Exactly. It can be written exactly as a fraction made of 2 integers. Right? So you can write it exactly as a fraction of 2 integers. Any rational root that exists to this equation as a solution has to be made up of these factors. Factors of the constant term, the last term when it's written in standard form, divided by factors of the first term when it's written in standard form, the first coefficient. So, what is my constant on this particular polynomial? 4. Now, we ignore the positives or negatives, guys, because we're going to slap plus or minus onto all the possibilities anyway. Okay? So it's just a number that we care about. What is the leading coefficient? 2. What are the factors of 4? 2, 1, and 4. Right? 1 times 4, 2 times 2. Those are the only factors of 4. Integer factors. What are the factors of 2? 1 and 2. So what we're going to do is we're going to make a list of possibilities. Okay? And that list of possibilities is going to be the following. I have to take each of these and divide them by each of these. So I have 1 over 1, I have 1 over 2. I have 2 over 1, I have 2 over 2. I have 4 over 1, and I have 4 over 2. I took each of these, and that's why I wrote the constant on the top, even though the leading coefficient comes first, because I'm writing these in the same structure that the fractions are going to be built. I have 1 over 1, 1 over 2. 2 over 1, 2 over 2. 4 over 1, 4 over 2. Now, in addition to that, I have to put plus or minus on each one of these, because I could have the positive version and the negative version as possible roots. Now, obviously, some of those can be simplified, right? And not only can some of them be simplified, but some of them can be simplified to numbers that are elsewhere on our list. So what does 1 over 1 become? 1 over 2 is just 1/2. 2 over 1 is 2. 2 over 2 is 1, but that's already on the list, so I don't have to write it again. 4 over 1 is 4. 4 over 2 is 2, but that's already on the list. And now I need plus or minus on each one. Now, to save you guys a little bit of writing, if you want, you are allowed to put plus or minus in front of the whole list instead of putting it on every single number. But in order to do that, you have got to put parentheses around this list, or I will mark it wrong. Because if you don't put parentheses around it, then that plus or minus only affects what number? Just the 1, right? So you got to put parentheses around it so it affects everything on the list. So how many different possible rational roots do we have on this list? How many? 8. Plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus 4. There's 8 possibilities. Now, we have no idea which, if any, of those actually work. But we know that if any of the solutions can be written as fractions, they are definitely on that list right now. Okay? Now, very important, guys, when you are doing problems, you need to read the directions, because sometimes they will not ask you to actually find the roots. They will ask you to list the possible, rational roots. If they ask you to just list the possible rational roots, what do we do next? Nothing. We're done. That's the end of the problem if all they want us to do is list the possibilities. Those are the possibilities. We're done. End of story. Now, this problem did not say list the possible rational roots. This problem said to solve, which means we have to actually find the roots that really do work. So what I'm going to do now is I'm going to erase this just to make some room. I'm going to move my list up to the top so it's a little more out of the way. And so now what we do is we go over here and we start doing synthetic division to see which, if any, of these are actual roots, so that we can begin our factoring process that we did last night. So I have 2x cubed, negative 1x squared, negative 9x, minus 4. I don't have any missing zeros to fill in. Which of these do you want to start by testing? I heard 1 first, so we'll try 1 first. Now, if this is going to end up being a root, how are we going to know? Remainder has to be 0. So all we're doing is looking for a 0 remainder. Now, my recommendation, do all this synthetic division on a separate sheet of paper so that you can do it very, very quickly. You don't have to be super neat and organized about it. Okay? I don't need to see all the synthetic divisions that don't work. I only need to see the ones that do work. So once you find the one that works, then show me that one on your homework assignment or on your test or your quiz. So 1 times 2 is 2. That's 1. 1 times 1 is 1. That's negative 8. Negative 8 times 1 is negative 8. Did that work? No. So therefore, 1 does not work. Let's try negative 1. And so now I can really just erase this stuff and do it again. Negative 1 times 2 is negative 2. That's negative 3. Negative 3 times negative 1 is 3. That's negative 6. Is this going to work? No, because this would have to end up being a what down here? No, not 4. Negative 4. And it's not negative 4, so I know it's not going to work. So that means that plus and minus 1 don't work. What do you want to try next? 2? So if we try 2, 2 times 2 is 4. That's 3. 2 times 3 is 6. That's negative 3. Negative 3 times 2 is negative 6. Nope. why don't we try negative 2? Two times negative 2 is negative 4. That's negative 5. Negative 2 times negative 5 is 10. That's 1. 1 times negative 2 didn't work. So those don't work. Okay? So you guys are just going to go through and you're going to keep testing these until you find one that works. You don't have to find all of them that work. You don't have to test all of them. You just have to find one that works, because as soon as we find one that works, we can start our factoring and finish the problem like we did last night. So let's try one that I know is going to work, such as negative 1/2. Negative 1/2 times 2 is negative 1. That's negative 2. Negative 2 times negative 1/2 is positive 1. That's negative 8. Negative 8 times negative 1/2 is positive 4. There is our happy 0. What does this look like as a factor? X plus 1/2. And then this was x cubed, so this is now 2x squared minus 2x minus 8. Now, can I factor this some more? Yeah, what can I factor right away? A 2 out. So I'm going to factor the 2 out. Don't forget I still have an x plus 1/2 out there. And that's going to give me x squared minus x minus 4. Now, can we finish solving this? Yeah, does it factor more? No, so what can we do? Quadratic. So we're going to use the quadratic formula on this. This one gives us our x equals negative 1/2. That's one solution. Does this give us a solution? What does that make x equal to? No, not 0. Doesn't say x equals 0 anywhere in there. Yeah, it gives us nothing, guys. There's no x to solve for. How can it give us an answer for x if there is no x in it? So we don't have to worry about that. Here we get x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So that's x equals 1 plus or minus the square root of 1 plus 16 is 17 over 2. How many solutions did we get altogether? 3. How many should we have gotten? 3. It makes sense. Always run that reality check on your work. Now, here's the thing, guys. What do the instructions say? Solve. Did we solve? Which of these 3 answers do we write? Yeah, all 3 of them. But what if it didn't say solve? What if it said find all rational roots? Now would I have written all 3? Nope. Why not? Because this one is not a rational number. Why is this guy not a rational number? It's written as a fraction. It's the square root, guys. Square root of 17 is not rational. Remember, it has to be written as a fraction composed of 2 integers. We can't make rad 17 into an integer. That's an irrational number. So now if these are the instructions, you would not write these. It doesn't mean that those aren't solutions. They're still 2 of our 3 solutions, but they would not satisfy the instructions in the problem. Does that make sense to everybody? So you have to go back when you solve these and reread the instructions to see what they're actually asking you to find. Okay, so that you know whether to include all your answers or not. Any questions about that? So do you guys see it's really exactly the same as last night? The only difference is we have to make this list and then start searching for the first one to get us started by finding a 0. Now, a couple of things. If they ask you for all rational roots, do we have to actually solve this thing all the way and get stuff that may not be rational? No. You could just test all 8 of these roots. Then you'd have to show me all 8 of them and show me which ones work and which ones don't, and the answer would be the ones that work. The only one that's going to work is negative 1/2, it turns out, on this one. But on other ones, there may be multiples. I don't recommend doing it that way, because doing it that way, we're guaranteed to have to do synthetic division how many times? 8 times. Whereas this way, we only did it a few times, and then we found the rest of the roots by doing our factoring. Guys, this list could be 24 or 30 numbers deep. you're not going to want to do synthetic division 24 or 30 times. Do it until you find a 0, then finish it the way we did last night by doing the factoring process, and these will come out to be other rational numbers if in fact there are other numbers that work on that list. But it will end up saving you in the long run a lot of time on those longer problems. Does that make sense to everybody? Okay? You can do it the other way, but you're going to spend a lot more time on certain problems doing it that way. It's not going to be a shortcut. Okay, it's going to be the scenic route. All right. Now, sometimes what you're going to get is a situation that looks like this. You might get something that looks like bear with me just one moment. Let's find one that I'm going to take one from last night. That's my easiest example. That's what I'm looking for. Bear with me. Okay, let's take x to the fourth plus 2x cubed. That's the one I wanted. X to the fourth plus 2x cubed minus 23x squared minus 24x. This is one of the homework problems that we just looked at, right? Plus 144 equals 0. Okay. We want to solve this all the way. They don't get us started, so we have to make our list. My constant term is 144. My leading coefficient is 1. The factors of 1 are just 1. The factors of 144 are 1 times 144, 2 times 72, 3 times, 48? 4 times 36, 5 doesn't go, 6 times 24, thank you. 7 doesn't go, 8 times what? 8 times 18, 9 times 16, 10 doesn't go, 11 doesn't go, 12 times 12. So this is our list of factors, and so our list of possibilities is going to be plus or minus 1 over 1, 2 over 1, 3 over 1, etc. So 1, 2, 3, 4, 6, 8, 9, what comes next? 12, 16, 18. You don't have to write them in order, but I just like to write them in order to keep track of things. That's a long list. Are you going to want to try and solve this by plugging all of those in with synthetic division? Go for it. You're still maybe going to find all the answers, maybe not. What we're going to do is we're going to factor this. We're going to solve this the right way. 1, 2, negative 23, negative 24, 144, nothing's missing. I'm going to start by using a 4, I believe. Sorry, negative 4. So we'll start by using negative 4. Just start somewhere on your list. Wherever you have a gut feeling, it may work out. So that gives us negative 4, which is negative 2. That gives us 8, which is negative 15. That gives us 60, which is 36. That gives us negative 144. And there's our happy 0. What does this look like as a factor? This was x to the fourth, so this is now x cubed. Excuse me. Minus 2x squared minus 15x plus 36. Now, I can't solve this or factor it yet, so what I'm going to have to do is I'm going to have to work on factoring it by doing this process again. So until we get this down to all linear and quadratics, we're going to have to continue to do this process unless you get lucky and this thing groups at this point, which this one doesn't. You can't get all the way to the end by grouping. So now what I do is I take my 1, negative 2, negative 15, and 36, But now, guys, do you see I have a new list to make? Now my constant is what? Now I'm working with this. What's the constant term? Okay, and my leading coefficient is still 1, so that still gives me 1. This gives me 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So I have 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, 8 doesn't work anymore, 9 over 1, 12 over 1, 16 doesn't work, 18 works, 24 doesn't, 36 does, these don't. So do you see that I have a new list now? It's actually a little bit shorter than it was before. Sometimes the list will be shorter, sometimes the list could be longer. More often than not, it's shorter or the same. So now what I do is I repeat the process again until I find another one that gives me a 0. So let's use -4 again. Maybe we'll get lucky and -4 will work again. Actually, we already know it does. 1 times -4 is -4. That's -6. That's 24. That's 9. There's -36. There's another happy 0. So this is another x plus 4, which leaves us, this was x cubed, so this is x squared minus 6x plus 9. So do you guys see how you may have to perform the process or go through the process more than one time? Until you whittle it down to all linears and quadratics, and then you can either finish factoring it normally if it factors, or you could use the quadratic if necessary. Any questions? No. I just did that because we already saw earlier today that -4 happens twice on this one. Yeah. You could try the same number, but more often than not, it'll be different numbers. I'm just trying to save us some time so I can get you some time to work on homework. Now, does this factor again? Yeah, x minus 3x minus 3. This is still x plus 4. This is still x plus 4. And so we get x is equal to -4 multiplicity 2. And positive 3 multiplicity 2. How many answers did we get? How many should we have gotten? There we go. So do you guys see how the process can be performed multiple times if necessary? Whenever you're facing x to the 4th or higher, there's a good chance you're going to have to do this multiple times. Just remember to make a new list so you're not trying things that aren't even possibilities the second time around. Because those numbers weren't factors of 36 over factors of 1. And we made a new list because now we're not using 144. Now we're using 36 and 1. So that changed our list. I would actually write a new list, not just go through and erase the old ones. I just did that to save space and time. Okay, guys, questions about the process? The homework assignment. Page 805, 1 through 6, 13 through 22.
How many more sections are left?
We have probably one more section in this chapter, I think, is all we'll do. Yeah, we're just going to do one more section in this chapter. We're not going to do the partial fractions this year.